So here is our problem. This is problem, again, is problem 2.3. So we've got four forces that are acting on bolt A, and we want to determine the resultant of the bolt. So once we add all these together, we want to know what the force, the overall force is. Okay, so we are just going to simply take and break each of these forces up into its X and Y parts. So we'll start with force 1. That was our 150 newtons. Okay, so if I look at this, I know that I have an X piece and a Y piece. So there's my X piece. It's going in the positive X direction. And my Y piece is going in the positive Y direction up to that. So here I know I have both components are going to be positive. So if we do F1x, that's what we want. That looks like a Y. Let's try that X again. There we go. That looks a little more like an X maybe. Okay, so F1x, that's our 150 newtons. So I'm going to use cosine to find that component. So I've got 150 newtons times the cosine of 30 degrees. And when we punch that into our calculator, we are going to get 129 newtons. Okay, I'm going to break up at the Y component. Y is going to use sine. So I'm going to put 150 newtons multiplied by the sine of 30, which is going to equal 75 newtons. Okay, so force 1 is broken up into its pieces. Okay, so if we look at our F2, which is going to be our 80 Newton force, okay, if we look our Y direction, I'm going to do the Y first this time. So we're going to use cosine of 20 degrees there, and then our X direction. That one is going to be negative. So we have to make sure when we do this that F1x, or sorry, F2x, that component, that we are going negative. Okay, so let's start first with F2x. Okay, force 2 in the x direction is going to equal, we've got 80 newtons. And that is going to be multiplied by the sine of 20 in this case, because it is our opposite side. And this is a negative, because it's going in the negative x direction. So our answer for F2 is going to be a negative 27.4. So 27.4 newtons. Okay, F sub y, F2 sub y, that's going to be 80 newtons. That is a horrible 8, but that's okay. This time we're going to use the cosine of 20 degrees to find our component. And that value is going to be a positive 75.2 instead. So we're at 150.2 newtons in the y direction. All right. So F3 in our diagram is this 110 Newton force. So, well, that one's easy. There's no x component. There is just a y component. So we're going to put F3y. It's going to equal a negative 110 newtons because it is going downward. Okay, last one is our fourth force right here. So we've got a positive x direction. And we're going to go back to that y. And this time the y is going to be a negative because I have to come down, okay, to the tip of my final, of my F4 vector there. Okay, so F4x. We're going to break that 100 newtons, and that is going to be times the cosine of 15 degrees. And that is a positive, so cosine of 15 degrees times 100 newtons is 96.6. Okay, so now we're going to do the same for the y, but we're going to use sine F4y is going to equal, and this is going to be a negative, so negative 100 newtons multiplied by the sine of 15 degrees. That is going to equal a negative 25.9 newtons. Okay, so to get my resultant, what I'm going to do is I'm going to find the resultant in the x direction and then the resultant in the y direction. Okay, just to get the components. So it's like I'm going to add all those together, and then I'm going to add all those together. Now your book actually uses a table to do this. They put the magnitude in one column, then they do an x component, and then they do a y component. Okay, you can do something like this, like I'm doing, to where they're just kind of all lined up. You know, sort of to add them all together, you can, you know, just list each one by itself. Just realize that to get your resultant, right, you're adding them all together. So my resultant in the my x component, okay, is going to be 129 minus 27.4 plus 96.6, and I'm going to end up with 199.1 newtons. So 100, oh goodness, let's try that again. 199 newtons. Okay, so over here, when I define the component, the y component, I'm going to add all of those together. So 75 newtons plus 75.2 newtons minus 110 and minus 25.9. When I do that, I end up with 14.3 newtons. Okay, so what we're going to do to get our resultant now is we are just going to put these two back together. Okay, so I've got a really long x piece and a pretty short y part. Okay, and I'm going to put those two back together to find out what the magnitude of r is. Now, I don't necessarily have to find the magnitude of r and the direction. If I put this in that Cartesian vector notation, okay, so I could put this vector, okay, I'm talking about vector r, and say 199 199 newtons I hat plus 14.3 newtons j hat. That is a correct answer. Okay, that's one way to list this vector. Okay, one correct way. Okay, if I wanted to do the magnitude and direction, we will call this angle alpha. Okay, if I want to know the magnitude and the direction of the resultant vector, all I'm going to use is Pythagorean theorem, and I'm just going to use tangent theta. Okay, so if I want to find the magnitude of r, I am just going to use the Pythagorean theorem and do 199 squared plus 14.3 squared. Okay, and I'm going to get a resultant of 199.6. That's about what I would expect. That sounds right to me because this leg is so much bigger than that one. Okay, so now to find oops, I put theta. I called it alpha, didn't I? Okay, so if I wanted to list this as a magnitude and direction, tangent alpha is going to be, that's going to be 14.3 opposite over adjacent divided by that 199. And if I take the inverse tangent of that, alpha is only 4.1 degrees. Okay, so that's a second way I can list that vector. This is Cartesian vector notation here. Okay, this is just magnitude and direction. Either one of those is correct. All right, we will move on to the next section in the next recording. That will be section 2.3b, where we talk about Newton's laws of motion.